Okay, for people joining this live stream, this is one in a series of meetings talking about synthetic geometry and Wolfram language. And let's take a look at what we've got here. So what we want to do here is represent this image and this question in our language. So let's see if we can understand this. So we have a geometric scene with a bunch of variables here that represent the points in the star. So it's A, B, C, D. I don't know where. I mean, we'd have to label it, but in order to get this. Counterclockwise angle. What does that mean? Why isn't what is an angle? Why do we have to say counterclockwise angle? Oh, because there's the angle on the outside as well.
Right. If you just put an angle, it assumes it's the angle between 0 and 180. But if you want to guarantee the shape you see above, you have to specify orientation.
What does counterclockwise mean here when you have BCE?
That means that the angle BCE at the vertex C, if you sweep counterclockwise 100 degrees, you'll go from the line segment CE to the line segment CD. Or I'm sorry,
which
counterclockwise from the line segment BC to the line segment CE.
Okay, let's take a look at all of these. So these are all the things that you are trying to introduce here. Is that correct?
Yeah, they include a few extra things just for to help with debugging.
Okay, but so there is a notion angle.
Right.
And I don't understand why this isn't some option to angle or something, because this seems very obscure here. I mean, in other words, well, let's take a look at what you, okay, so then
So
given this.
Yeah, draw the scene.
Okay, why aren't those labeled in some way with
they're tooltips.
I think it should have a label, shouldn't it? Why not?
Sometimes we've been
so
worried about clutter.
Roger, can you comment on this at all from experience with graphs and so on?
I think you're going to have to, I think it's going to be work to manage label placement. I think it should be done, but I think you have to have kind of this overall objective of being able
also,
to
where did we decide that the nodes should be in this? I mean, because the nodes, if this angle was a named angle, what would it look like?
If you, so currently angle refers to just angle measure. So if you can't really name an angle.
Okay, so let's imagine that I just didn't do what you told me to do here, and I get rid of counterclockwise.
Yeah.
Okay. And then I say
find geometric scene instance at this.
Okay, so that time it worked just fine.
Right. It might.
So you're saying if I make a table of multiple instances of this, that sometime it might flop around in some weird way.
You can. You don't need to do table. Yeah, you can just do get rid of table. And
what just happened there? What just happened?
These are really small. You have to expand them. So what you'll want to do if you want.
Why did it do that? Why did it do that when it got really small? That's wrong.
Right. Well, so if you do find geometric scene instant.
No, wait a second. Wait a second. I don't care about that. I want to know, why did it go wrong when it got small?
Probably something to do with absolute versus relative sizes of the elements.
Okay, so it's wrong right now. So those are wrong right now. So they need to be fixed. Right? Makes sense?
Yeah.
Okay, so what's your points here? These are all looking hunky-dory. Well, they're differently configured, I see. So C here
Right.
Well, no, these are fine. What's wrong with this?
Nothing seems to be wrong in this instance, I guess.
Well, we've got 5 instances here,
Right.
and so far nothing is wrong. But you're saying there is a solution, you believe. Ah, look at that. 5th time lucky. What's that? Something's gone very, very wrong here.
Right. Well, for complicated enough scenes, every once in a while there will be a degenerate case.
Okay, so hold on. What does this mean? What just happened here?
So the way
I don't get this. I don't get how this managed to get. So the angles here, this is, what is the angle around A? Hey, whoever's making background noise, could you not do that? HAB is 40 degrees.
Yeah.
Okay, so where's H?
Is collapsed under A or one of the other points.
How could it be collapsed under A?
So
where's C? How do we know? I mean, this kind of degeneracy, right, is obviously if points are on top of each other, it's not an adequate solution.
Correct.
So do we not test for that?
It's kind of impossible to test for that without eliminating some user, if the user specifies that, points are supposed to be very close to collinear or something, then it's kind of hard to test.
Well, so look up whether the user specified that, and if the user didn't give any such condition, then worry if the things are degenerate like this. I mean, you look, worst case, you just try another random seed.
Right.
So the question is, are you rejecting this? And how many random seeds are you typically trying to get the solutions you do get?
Depends on the complexity of.
Okay, but I mean, are we talking
input.
1 or are we talking 10,000?
Closer to 1 than 10,000.
Okay.
The max iteration limit is, I think, set at 150 now, and every once in a while it'll.
So here's a question: could we figure out if we've got 3 of these, 3 different instances?
Yeah.
And we ask the question, do they look similar? Okay. If we could answer that question, then we could reject this one. Am I making sense?
Yes.
But the word similar, you mean not in a technical sense?
Not in any kind of technical sense. I mean, visually, and I have no idea whether this is doable, visually, do these pictures look, I mean, I have no idea whether we can do that. I mean, that's a kind of machine learning adventure.
Well, I mean, the way we would do it is we would see which points, all we really care about are which points are a non-trivial distance apart from each other. Because, the way it's set up is if...
okay, so in other words, the distance matrix of those points, you're asking, are there zeros in that or close zeros in that distance matrix?
Right. And we might also need to check collinearity, because sometimes check that points are non-trivially far apart, and if they're putatively not supposed to be collinear, that they're not collinear.
So fine. So that's a possible thing to do. Yeah. So because I think we need to avoid that kind of degenerate case.
Yes, we know this.
Okay. And also something's wrong with the sizing thing. You'll deal with that. Okay. Right. Now let's talk about this angle thing.
Right. So they have a clockwise and counterclockwise angle, and I'm not sure why you don't just have an angle and a directed angle. I mean, if you look at the literature, right, there are 2 concepts of angle, right? There's here's an unordered pair of line segments that meet in a point, and here's an incoming line segment, and then you rotate from that. So why do we need a clockwise and counterclockwise as opposed to just
or alternatively
directed angle?
There's also quite a bit of more material related to angle further down in the
Right.
notebook.
Yeah. So we're just at the top. We're just kind of showing you the workflow. Honestly, the majority of this notebook at the end is a discussion of angles.
Okay, fine. I mean, I would just like to make the possible suggestion that that might be a way of dealing with a directed angle.
It is also important to differentiate between an angle and an angle measure.
All right. Okay. Fine. Let's go further down in this notebook. Okay. So let's keep looking at this workflow. Okay. So let's take a look at this. This is a geometric scene with actual instances for the coordinates of the points.
Right. So this is the input form of the scene you drew previously.
Why are we using hold form here? I don't understand this. Why is this not?
There's some auto evaluation problems with also, so like infinite line will auto evaluate if it's inputted a list of
Yeah, so we need to fix that because that clearly we're not going to have a hold form.
right. The hold form is just for us now.
Okay, but so how are we fixing those things? Is the infinite line evaluating because of something that's done for some other purpose, or is it how is that going to be fixed?
I believe. Well, I can let Charles and Itai probably speak for this, but I believe that they're planning on ending the auto evaluation of infinite line, where if you have infinite line of list A comma B, it adds in a 0, 0.
On this subject? Is Charles here?
Charles should be here.
Is Roger here?
Yes, but I don't know why it's auto-evaluating now. Normally we do it to canonicalize, to get rid of cases, and that's usually an important thing in sort of implementation cost. So,
yeah. So
I'm not sure what.
Can somebody find Charles if Charles is not here, or is Charles here?
Charles is not here.
Charles is off today, actually. Charles is on PTO today.
Okay, so who knows the answer to this question? Do I have to go research it myself?
I mean, you can't.
Yeah, well, just can say that it isn't clear how to get an answer.
But does it document that there's auto-evaluation of any kind?
No, I mean, like
it's not supposed to. Okay.
I mean, the whole system is built like that, Stephen. I mean, I mean, what special functions auto-evaluate? That's been killing us for endless years.
Yeah. Okay. Fine. But you don't think this is supposed to be auto-evaluating?
I mean, normally we have things that auto-evaluate. They're supposed to do that. That's a
okay, fine. So you guys will resolve what's happening.
And it's usually a whole architecture behind it.
All right. So you guys will.
Everything has to be aware of it.
Right.
The graphic system needs to be aware of it. Everybody needs to be aware of it. The cost goes way up.
Okay. Right? Bottom line here is there shouldn't be a hold form there. And Peter and so on, you need to figure out what needs to be done to make sure you don't have to have that, right?
I think there are two possibilities. Like if most of our functions evaluate, they do some non-trivial computations. Here we are mostly concerned with representation. So the two worlds have some friction between them.
So let's find out what the issues are.
So potentially we have to use inactive to represent
whatever. Them. Peter has said there's an issue with infinite line, but he can't tell us what it is. So
and I don't
for us to justify having this.
Well,
but just so you know, I mean, it's usually not stupid, Stephen, what's done. I mean,
I agree. I agree. So it's probably and the question is, why does it even matter to hold? But because the canonicalization you're doing, I'm surprised that meshes badly with the synthetic geometry stuff, and I'm suspicious that it doesn't.
Well, so
what happens if they stick in like an arc length or
right? That's also a problem. So, like for instance, arc length will get mad if you don't.
Okay, you know what? You guys have to sort this out, okay? Because that's probably an error message for arc length that it probably doesn't need to have.
Right. That's not unusual that we have to look at that.
Yeah, I know. As we turn it into meaning something symbolically.
Absolutely. Yeah.
So okay, let's make a meta point here. This is coordination between multiple groups. We don't have a project manager for this. We probably should have a project manager for this if we're going to have to coordinate between these several groups. Or does Peter think? It doesn't seem like Peter is handling this, so I think we should ask.
I think that Charles is sitting in on regular of these meetings. So
Yes, we have monthly meetings to coordinate.
Right.
So maybe
Right,
that's
okay.
not quite
All right.
often enough.
Okay, but so somebody organized this meeting when Charles wasn't here, which was a mistake. So let's make sure we don't have any more of these without Charles in them. Fair? If he's the one who's supposedly coordinating between these efforts.
So the issue with infinite line is the following. There's a one argument form with a list which assumes that the other point is 0, 0.
So if you evaluate infinite line of list A, comma B.
I get it. I understand. Infinite line. A one argument form with A, B. Whoops, line. Then you get that. Okay, right. What do you want infinite line to mean in the case? The
documentation is that infinite line of list P1, P2 represents a straight line from P1, P2. But the question is here, is A now a point or is A a coordinate?
Yeah, I mean, this is the basic problem we have with symbolic variables. They are assumed to be scalar complex numbers. And here you want them neither to be scalar nor complex.
Correct.
Yep, we've been fighting that everywhere.
Yep.
The hardwired types.
Yeah, well.
Looks like Charles just joined.
Yes, I'm here.
Oh, okay, good.
Do you see Stephen's screen?
Yes.
Okay.
The question is like, should this happen?
Yes.
Then can we have a problem?
Well,
I don't.
No, let's let Charles answer why he thinks this should happen. It isn't even documented.
Well, when you say it's not documented, I believe at the time, Stephen, that was actually one of your requests. Several of the constructor auto-evaluate to some sample case. It was your request. And especially when you want to do essentially computation analytic, you need to actually assume that those are fixed value, you simplify them or you canonicalize them to a sample form. And this is actually one problem, Michael, we discussed, right? I mean, that's the main issue with the synthetic geometry.
Yes.
Yeah, well, so I'm probably wrong. I mean, there's an overarching reason why we shouldn't do this one argument form like this. I mean, this is also what we get in synthetic geometry for not decorating the ABCD here, right? I mean, this is, the other way of doing this is to decorate those, variables and not have them be naked symbols.
Why would this help?
Because then we could easily make infinite line on a decorated, point A, point B or something. Geometric point A, geometric point B doesn't have to evaluate like this.
Yes.
Okay. But of course, then it gets much more verbose, everything.
Well, I understand. So, right. Okay. So let's inventory what cases there are of auto-evaluation that cause us trouble with geometric scene. Okay. Are there lots or are there like 3 of them?
So besides, there's infinite line, half line does the same thing.
Okay.
And then region things like if you do area of A, where A is not an explicit region, it doesn't like
what does
that.
it do? It just gives an error. Okay. That's fine. So that error doesn't need to happen.
Right. So basically, the only auto evaluation problems are infinite line and half line.
Okay. Well, so that was a case apparently added in response to a comment of mine, not documented and not necessarily necessary. So if that's a little tiny thread on which this whole issue hangs, I think we can fix that. Make sense? But let's make sure that there aren't other ones lurking that are more serious.
Right. So I will agree with the point that this is the only reason, then that's, we should get rid of it. But I will also
it depends on what you mean by. It depends on what you mean by tiny. I mean, auto-evaluation, we have, if you do circle with no argument, we auto-evaluate with 0, 0.
I doubt that that's problematic here.
No, that is actually fine. That I can deal with.
Right, but so let's inventory what auto-evaluation there is for these things and whether it does or does not cause trouble for the synthetic geometry stuff. And let's find out, you know, whether this is a tiny thread or whether this is a giant piece of rope. Fair?
Right, so Stephen, I agree with all that, but I just want to make the counter meta point, which is that we do have cases where if we have a wrapper that's not hold something, that we wrap things in hold inside of it to carry around metadata. So,
Stephen, in this case, we actually already discussed that, and we actually came to a conclusion. We decided which method we should remove and where we should hold auto evaluation. Michael, I believe we did that a while ago. Right?
Yeah, we did.
So
Which?
I think that's not a problem, really.
I'm sorry. What are you saying?
I think we solved this problem already. We had it.
We discussed it already with Charles.
So wait a minute. So this problem has gone away, or this problem is still there?
It will be fixed. That's
Okay,
in the class,
fine.
as well as the.
Excellent. Good, happy ending. Okay, let's move on. Okay, find geometric conjectures.
So, so if you evaluate this, it'll on top return the scene, but the input form has an additional argument, which is.
Okay, but you're not seriously proposing this as being the way that you get this out.
I didn't like it.
It's supposed to format as a tab view where you can tab in the different.
right,
No,
and
I don't
have
think
to
that's
say
very
that
convincing
if
either.
I type in something which is called find geometric conjectures, and
Yeah, you don't want to get a
that's exactly
picture out
like the
again.
scene.
Right.
That is baffling.
Yes.
Right. So yeah, I would think the solution would be the same. Would be you have the input form be the way we have it, but instead of formatting as
No, I don't agree. Look, if it's called find geometric conjectures, return the conjectures. Don't return the scene. Why are you returning the scene?
well, no, I mean I think the input form I like as is, but instead
Why
of
does it need to return the scene? You asked for the conjectures. Why isn't it just returning a list of the conjectures?
Because then it kind of makes many things naked without context and meaning.
Okay. But this is a geometric scene, and you're annotating, you're having a third argument in the scene that is the conjectures?
Right. Yes.
It's pretty weird.
I mean, I would argue that, definitely instead of just drawing the picture again on the top level, it should be some
Obviously, that's
list
just
of,
ridiculous, right?
Yes,
That's
no
ridiculous.
question. No question.
Right.
So why not just have a geometric conjectures, which maybe it had the arguments are the same, but you just change the head and we can do whatever the hell we want with the typesetting.
No, but also, well, hold on a second. The issue is, what are you going to do with those conjectures from here? You're probably going to extract them and start doing things with them, but you've now got these.
Sorry, but what would you do with them?
Do you expect to? Can you visualize the conjectures, just as you visualize the scene?
Yes,
exactly. I don't know what happened to that formatting. Lynn's original code did visualize all of the conjectures, and that's why it was in the geometric scene, so that we could attach the formatting to them.
Okay, so something is broken here.
Yes, there's something.
Okay, but so are we also going to have extractors for the geometric, for this thing, whatever this is, sub quotes conjectures or something, to extract just the conjectures? So you're not doing this weird input form last.
Yes.
Whatever.
Yeah.
Okay.
I still think it should be a different head,
Probably, yes. I'm not sure, though.
And then
What else have you thought about? Have you guys thought about what you want the conjectures for? What are you going to do with them next?
Well,
the only realistic thing is proving them.
Okay. So prove them. You talked about visualizing them, proving them, and admire them in some way. Right.
But in particular, you probably want to pick out a particular conjecture that you want to prove, visualize, or whatever.
Right.
So previously, this
and let me point out that find geometric proof, you take this extracted thing and then you give it the original scene, not the conjectures, which why not? It takes the conjecture and you give it an index or something. Or if we wrap them all up into this big thing, why not do that?
Well, I don't understand. Find geometric proof. I mean, first question is some given result actually true?
Yeah, you can ask that by putting in a pattern without any blanks.
Okay, but how would I do that? By asking for find geometric proof?
That's the only way so far.
So you want more a Q function.
That's what I'm saying. I'm asking the question, can I tell, are blah, 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 and blah collinear?
So far we can just return a proof of that, or if there is no proof, then to
okay, but I mean, is it faster for you to tell whether it's true than to generate a proof?
No, not to tell.
What the heck is that?
No, I don't know. The first error is very strange.
It means you have a mismatch between the template, message template, and the arguments you're feeding it. So that's some bug in your code.
Yeah, I actually just started getting that today, and I was confused about that.
Oh, yeah.
But I don't think I changed it.
No matter.
So
what that means. But...
So this now was a proof that has 51 steps and doesn't find.
Okay, but this says equational logic. So why would that proof network not come out? Is it called proof graph or something?
Yes. So below, you can look below where I do that, and it's. Yeah, I shouldn't have let you do that. If you just look below, there's the proof graph, and it's called proof graph 2 because it doesn't work right now. It hasn't been.
It's just in the process of getting it into the framework of find equational proof. That's not yet ready.
Okay. And so these are the lemmas. Is that right?
Yeah, the ones with the red arrows going to them are the givens, and then the lemmas are everything else. And the last one is the thing that we asked for.
So these are constructed lemmas that the system came up with. Is that correct?
Yes.
Are they technically comprehensible or not?
That's mirrored exactly by the 2-column proof above. I wish you could click the facts tab, but you can't.
Okay, fair enough. So when you do this in practice, do those lemmas end up being comprehensible things, or are they something totally weird and computeristic?
No, they're comprehensible. I've engineered them to be as comprehensible as possible. And I have these nice forms for them, as you see in the 2-column proof, but I could use some help and some work making those maybe a little better.
Wait, are you sure hitting the facts tab won't work either?
No, it's an image. Oh, okay, never mind. Sorry.
Yeah, it works.
Yeah, you sent the notebook.
Right now,
so those periods, the decimal points should be suppressed somehow.
Okay.
I think that's an issue probably in angle formatting. That's a quantity formatting issue, I think.
Oh, okay.
Yes. But this proof thing is just right now to show kind of how the workflow continues. That is not quite ready for detailed discussion. This needs more work. Yeah.
Do whoever's typing very loudly mute themselves?
Yeah. Okay, so
coming back to, we could have had geometric conjectures, and if you're on the conjecture mode, we show conjectures, and then conjectures of scene could make conjectures, and scene of conjectures could discard conjectures.
Maybe.
To round trip.
I'm still a little bit unconvinced what we're going to do with these conjectures. The problem is what happens when you take a conjecture out and it has naked symbols representing points.
Right.
And, from some point of view, you could say, well, oh my gosh, it's so scary to have a polynomial with naked x's and y's representing, things. So, just don't worry about it. Just say, okay, you take it out. If you've already given f some weird value, you're going to get a stupid answer. But that's a different issue. You put f in, you can bring f out.
It will already make earlier trouble because nothing is held here.
No, I understand.
Okay.
I understand. Right. So my point is, just like you could be scared of a naked polynomial, you could be similarly scared of a naked geometric conjecture. Just let them come out. Am I making sense?
Yeah.
And that way, sorry?
I was going to say that, yeah, if geometric scene is not hold anything, so it's protecting them somehow, then,
they can just hang out there. And I would argue, I mean, there is a slight scoping issue, and I don't fully understand that, but I would argue that fine geometric conjectures should just literally give this as a list without any other tentacles, without anything else. In other words, you could make the same argument for a polynomial. Oh my gosh, I don't know what x and y mean. After you do some operation on a polynomial or a Boolean function or anything else that has variables.
But then if you want to nicely visualize this, you need a function that takes two arguments, the conjectures and the scene, which is a little bit...
Is that really such a stupid idea? I mean,
I would say
because you often want... What's that?
It's a little bit unusual. When do we generate two things and then unite them again? If they really are most useful united, then we can keep them united from the beginning.
Every time we call map thread.
Yeah. Okay, let's keep going.
I was more meaning a solve integrate like function where you never kind of split.
Well, eigensystem
keeps it together.
Well, that one does, but eigenvalues and eigenvectors does not.
Yeah, typically you're at the end. When you have an eigensystem, what operation do you apply to the values and the vectors together to make something new? Typically nothing. But here, the visualization is a very common operation where you need both.
Yeah, I understand.
Actually, the most common.
Argument. Right, okay. But let's keep going here. Okay. What types of angles?
I think we're going to take that out, right, Dan?
Well, that seemed to work. Just skip over that. Skip to the next section.
Okay. All right. So I'm just trying to understand here. So this, yeah, I get this. This is pretty nice, pretty interesting. Okay, let's keep going.
So these are just kind of examples of scenes you can draw and some functionality we've added.
And you wanted style to work, which now works.
Right. So style, you can...
Style works, but it is ignored, so to speak.
No, it works. No, so this is, right, so you run this. Right, so you made the certain lines and points red.
Okay.
You can do it. We also added we decided... This is
pretty nice. I mean, this is quite impressive, actually. Okay, so hold on a second. So this is now, I see. So here you're using strings because you can use anything.
You can use anything.
And I think this is what we should use in the documentation.
I kind of agree with you.
Yeah, it's definitely safer.
Okay.
So one...
Incidentally, in terms of the evaluation issue, I mean, clearly the infinite line thing certainly wouldn't evaluate with strings, but well, whatever, it doesn't matter. It doesn't matter. But well, that problem is being solved separately.
Right.
What does this even mean? Infinite line list AB. What does that mean?
So this means that it's an infinite line that just goes through the point AB. It doesn't say any other points.
I see. But why does it have a list in it there?
So because infinite line takes a list of points that it goes through. So
now, but that's the thing that we're hopefully changing, right? To allow it, because infinite line, wouldn't one expect that infinite line of a single thing there would mean the obvious thing?
No. There is a point called AB that it's going through.
Right. So if you do infinite line of list A, string A, string B, string C, it will be an infinite line that goes through those points A, B, C in order.
Fair enough. Fair enough. Okay. And presumably I mean, many times these diagrams and so on will be generated by some kind of drawing tool that has an infinite line construct that you can simply put in.
Yeah.
Is that true?
We are making some first steps in this direction.
Yes.
Okay. All right.
But you should stay a moment with the geometric property. We discussed it the last times, but
what is this? Sorry,
I had a feeling you didn't fully sign up on it.
I didn't notice it here. Okay, hold on. So this is a whole boatload of different random properties. Is that correct?
Correct. We also use it lower for perpendicular.
So this is an alternative to saying, okay, so there's a quality which is, and we have certain things like collinearity, is that correct? Which is its own separate, broken out function. And then we have the kind of vast collection of other geometric properties, like, is this, I don't know, is this on the circumcircle of a triangle or something weird like that, which we are doing with this geometric property thing. Is that the idea?
Yeah, I think collinear is a geometric property.
Okay, well, good, fine.
We're proposing this instead of having neat symbols.
We can't hear you, Ian.
Give me one.
Basically, instead of having a ton of symbols that I think the region group would feel kind of obligated to support right away, we're at least starting with this geometric property head that's clear that it really only applies to inside these geometric scenes. And it has
Do we like the name geometric property, or is that going to cause us yet another property disaster, so to speak? Roger and Charles?
No, I mean, it's called geometric property. It's fine.
No. But the property thing that you have for graphs, which I hate so much, is this compatible with that usage or not?
No, it's not.
Okay. And nor is it compatible with the entity property notion. So
I would even say that's a totally different notion.
It is a totally different notion, but it has the word property in it.
Yes.
And I'm just trying to find a different name here for this. It's geometric
feature.
I was thinking of feature, but that seems awfully weird and sounds like feature extraction. I mean, it's a geometric truth in some sense. It's a geometric
assertion.
What's that?
Geometric assertion.
It's not terrible.
I like
right, and that's actually closer to the way it's using because we're asserting this to be true in this picture you draw. Yeah, that's not bad.
Is it assertion or assert?
I think it's an assertion.
I would say assertion.
Okay, fine. Well, that's definitely better than geometric property. So, fine.
I like it because it also extends language-wise a little bit better to the multi-argument case.
Right.
What do you mean by multi-argument?
Scroll down to the next. Are you talking about multi-argument of the second argument or of the first argument?
Of the first one.
Okay, well, scroll down. Stephen, scroll down. I showed the multi-argument version of the first one, but it's a little confusing in this case. So scroll down.
Well, here. Okay, fine.
Right. So if you want to do this all at once, you can do lists of infinite line.
I see a list of those lines all being perpendicular.
Yeah. So.
Okay, but so let's take a look at this again for a second. So you're saying geometric assertion that those things are perpendicular. That's pretty reasonable, I think.
Yeah. I think that reads much better. I like it much better.
Okay. And why is this midpoint not also a geometric assertion? Because you actually want the midpoint out as a thing, so you might as well do it this way. The midpoint is actually an unidentified object, whereas this thing here is a mere predicate, so to speak.
Right.
Yeah.
Okay.
Yeah.
Fine. So equality is the only predicate that is sort of broken out outside of geometric assertion. Is that correct?
And element.
Okay. Fine. Okay, that makes sense. So those are the two things that are assertions but are not in the kind of big bucket of geometric assertion.
I
Yes.
believe so, yes.
Michael Hale on a live stream is asking the question whether it should be geometric constraint rather than geometric assertion.
It's
my only worry about that is, people are suddenly going to start worrying about holonomy and such things when you talk about constraints.
Well, it also might not be satisfiable.
Right.
Well, what do you guys think? I mean, Michael, what do you think?
I have a slight preference to assert. It sounds a little bit friendlier and more inputty.
Yeah, fair enough.
Although, as the developer on the fine geometric scene instance, geometric constraint is actually very similar to how we treat these inputs. So it is.
All right, so let's.
I feel like from the narrative point of view, you have a scene in the case of an image in front of you from some textbook, and you assert this is the case. You don't think there's the infinite space out, and now I put constraints after constraints on. It's an equivalent viewpoint, but I don't think such a natural.
Yeah, fair enough. Okay. Also on our live stream, Ron Anderson is asking if this will be available for spherical geometry, and I think that's a looking gift horse in the mouth type situation. This is hard enough to do.
Yes.
This is hard enough to do for the plane geometry case, and we're proud of being able to get close to being able to do it. Let's cross this bridge first. Okay, so let's take a look.
So one thing right. Okay. So just one note is that this multi-argument form of geometric property / geometric assertion / geometric constraint. It does not match. It's very close to matching how style works, but does not exactly match because style does not allow the multi-argument form for the first argument. Is that something we should allow, at least in geometric property? For instance, if you want to make a bunch of things red, currently you have to do a bunch of commands rather than one command where you list all of those things and say they're red.
I see. I think you might as well let style sort of be list commuting, if you understand what I'm saying.
So you're saying support that?
I think so. I mean, okay. by list commuting, I mean that style of a list is equivalent to a list of styles.
Right. Yeah, that's how I treat the geometric property stuff. It's not documented for style, I don't think. But
and the related question we discussed is sometimes you want to style the property. Not every property is stylable, but say if two lines are perpendicular, you might want a little dot with a quarter circle.
Yeah.
So around whom do we wrap the style?
I think probably around the property name, around the assertion name.
Yeah, I think so too. It's a little bit odd, yeah.
It's a little odd.
Yeah, just making sure that everybody understands the consequence.
It's a little odd, but I think it's the reasonable thing to do. I think it's understandable.
Yeah.
Okay. So this is a simpler example, kind of boring.
How did you manage to? Why is this gray inside? Oh, because there's a polygon, but that polygon isn't saying anything, right?
So we decided to make it gray. So if you put style, comma red, we don't want the user to have to change the opacity.
I can hardly see it's light green, but
right. The opacity, if you
you've preset an opacity.
Yeah, the opacity is currently 0.1. It was 0.0. If you want to change the opacity, you can put it in the style thing. But the idea is if the user puts in red, they're going to get frustrated if they don't realize that, oh, the opacity is set to 0. I need to change the opacity.
It's a little bit what we do with, say, countries in geographics.
I think it's the right thing. I think opacity is orthogonal to the hue and
I think so too.
The other color qualities.
Fair enough. So there's default opacity, but I don't understand. Saying polygon there is very different from. I mean, polygon is just like, okay, polygon, great, that's nice, but so what type thing.
Yeah, well, it's just saying to draw it.
I see. So in other words, if I were to put here circle, quotes a. I don't know.
No. So you need the first circle. Right.
Cool.
Right. So also, polygon actually does have a built-in assertion that the polygon is simple inside geometric scene.
Right.
So,
I see.
Inside your context. Yeah.
Is that supported? So Roger and Charles, I mean, is that correct going forward, so to speak?
No, not at all.
Polygon doesn't do it. Its fine geometric scene instance makes assumptions about points that are inside a polygon.
But is that the polygon that is going forward that is going to include holy polygons and things like this?
But for the audience who wants to use this tool, they don't want a multi-connected hold whatever property polygon. That's not the understanding of a polygon in elementary terms.
I understand, but if we are going to make our polygon directive support weird multi-polygon things, then that's a bit inconsistent here.
I mean, it already supports multi-polygon. It's.
I see what you're saying. So it already supports a bow tie.
The polygon life is rich, Stephen. Unbelievable.
Yeah, okay, so wait a second. So if there is our polygon can render a bow tie, correct?
Correct.
But this polygon will prevent bow ties. Is that correct?
Correct.
I think you guys are just treating it as an unsaid assumption.
In the documentation, it will be said.
Okay.
Okay, fine. But so if you wanted a polygon that could be a bow tie, you're out of luck for right now.
Correct. I could, in the code, I could say if all of the point inputs are concrete, then to just draw it without any assumption, in which case, yeah, you could get a bow tie. But currently, you would have to draw a bunch of line segments to look like the polygon.
Oh yeah, I understand. So the polygon itself has an implicit assumption of being, I don't know what you call it, simple. Okay.
Yeah.
Okay, that's probably okay.
So then this is just another way of saying the same thing with geometric property again.
What does cyclic mean?
Means that the vertices all lie in a circle.
Really?
On a circle?
That's not what I
That's a really weird.
Yeah, I thought that meant, like a permutation. I thought cyclic meant in a cycle. No, that is a crazy name for this.
That is extremely common. Yeah. It's another meaning of cyclic. Talk about cyclic polygons.
Wow.
That's weird.
Okay. All right, we need a different name for that doesn't confuse me and Roger, who are, admittedly, we're not necessarily the center of the market for this, but we shouldn't be confused.
If we avoid confusing you, then we will guaranteed confuse all high school students using this.
Yeah. Well,
but it's a string; it will not do any harm.
No, but isn't that we said cocyclic or concocyclic?
Yeah. So Charles suggested concyclic, which
you say that a group of points is concyclic. You say that a polygon is cyclic.
Yeah.
Concyclic means for a group of points.
Look, we got to do something about this. This is not a supportable thing. It's too weird. What would be the way of, okay, so you would say geometric assertion of a ABCD list ABCD comma concyclic. Is that what it is right now?
I don't think concyclic works. You could just do circle through of ABCD.
Well, why doesn't this just say circle through in the polygon case as well? Circle through is a much better name than concyclic in my opinion.
So circle through will if you circle through, you have to do circle through of the points, and then if you also want the polygon, you have to do polygon of the points. So the geometric property of polygon comma cyclic just eliminates one of the arguments.
I'm sorry, what do you mean? Polygon?
No. So circle through is a constructor. It's not a.
Oh, I see what you're saying. Okay,
right.
Fine.
If you want to, we could also
need to combine that somehow into this. Well, maybe we did a name here because circle through is a nice, clear. I mean, really, what this is has a circle through these.
Right. Well, so we could use circle through. I would like to keep it as the constructor, but we could also.
It's a fine thing for the constructor.
Right. We could also use this too.
What about points on circles or vertices on circles?
That's so obviously correct.
For what it's worth, we use cyclic polygon on Math World.
So what?
So what?
Math World doesn't know what an n-sphere is, so,
Yeah, I don't think vertices on circle is beautiful either, but we got to do something about the cyclic thing. And okay, we're of course running out of time here, but let's take a little look through some more of this. Let's talk also about speed. Is the speed we're seeing here what we can expect to see, or is this
the simpler the scene, usually the better it is. If you specify a bunch of angles, then that slows it down. I've improved the speed on especially like regular polygons and stuff, which we'll see in Botima's theorem next.
By the way, another question. Do we have a plan for a repository of known theorems? Since clearly we can, what's that?
We have a set of known theorems for tests, so we could make a repository out of it.
I think it'd be nice because, I mean, clearly a bunch of these are very well defined. We now have a well-defined way of representing them. I mean, in particular, the theorems. So how would we represent the theorem? We would represent it as a geometric scene. Is that correct?
With the conjecture argument filled in.
Why are we calling them conjectures when they're things that come out and are known to be true?
Yeah, we discussed having maybe some more structure in the conjecture argument to differentiate between proven ones and raw conjectures.
Why is there a raw conjecture? What do you mean by a raw conjecture?
One that we generate, but we don't know if it's true.
Right. We generate based only on the coordinates returned by the find scene instance, whereas the theorems are returned by the prover and have an accompanying proof.
Okay. Well, I don't understand. I mean, I understand that distinction as you're describing it. I don't think the design is right in terms of. I think that's crazy. I mean, the theorems are lovely nuggets. The conjectures are, they might be a diamond or they might be a fake one or something, right?
Right.
So
that's why they're called conjectures, right?
Well, I know that, except that here we're saying that they're all in the same bucket.
No. The bucket is divided, potentially.
What would be interesting
at the moment they're not.
I mean, I think it would be interesting to have a sort of a curated collections of these, statements. Should one also provide proof in those, or should one just have the statement? They know it's true, and then you can run the system to generate a proof. Or
I think it'd be nice to have the proofs as well. Particularly,
yeah, we should have a proof verification object like they do for equational logic.
Yes,
so I'm working on that. That's a lot cheaper.
Right, but I mean, how many? Just to give me a sense, how many theorems can we expect to have in the in a theorem repository for this?
Low few hundreds.
That's still pretty nice.
Yeah.
How many are like in Math World, for example? Comparable number?
Didn't we not look at this?
I was at the top. I was
Like a
thinking
few dozen.
200.
I want to say 70, but I'm not sure.
I see. Okay. How many named theorems are there of this type? I can't imagine there are many more than hundreds.
I was thinking low hundreds, which is what Michael said.
I think so too.
Okay. If I wanted to say that this was not regular or something, is there any way to do that?
No, not currently. The not is currently you cannot say negations.
But then rather than wrapping a knot around, we would make a new string not regular.
Right. Well, so you could one of the problems which I could work around is, internally this uses find minimum with IP opt, and that the constraints passed to that are kind of limited. So like an inequality that can't handle, but if you do a strictly less than or strictly greater than, that works. So I could probably translate into something that it could handle in certain instances at least.
Okay.
But in general, if you do a not statement and you try to keep it general, it will completely slow things down to.
Okay, whatever. But I mean, that in principle, okay, so the geometric assertion thing, in principle, there could be a Boolean combination of geometric assertions, logical combination of geometric assertions. You could say this one and not that one, this one or that one. In principle, I'm not saying we could do that today, but that's...
In principle, yes.
What is this? What is that 3 doing there?
So that 3 says we're getting 3 instances.
Why do it that way? Is there an advantage speed-wise to doing it that way?
There's slight advantage in so you translating the user input, you can just do that once, which really doesn't matter. This is more for.
I think it's mostly parallel to find instance.
Right.
Fair enough.
So to see what's going.
I mean, then why are we doing the tabbing? Find instance would give a list. I mean, we should as much as possible do things where we can actually compute with the output.
Okay, so
but it's still a geometric scene, so we can compute with the output.
This tab thing is still a geometric scene?
Yes. If you do input form on this, it's a geometric scene.
We keep everything a geometric scene.
Do you like that, Michael? That it's
I like it because of this first argument that specifies the point. I do not like making part of them naked, kind of taking their context away. That's why I like keeping them all together.
Yeah, but why not a list of geometric scenes as the output?
As the format or as the output?
What's that?
As the format or as the output?
No, I'm saying that the format would be a list of...
Yes, no. I think actually it should be similar to manipulate and others, where we have an option that says how it's to be formatted.
Okay, but do you have a reason why you think the tabbed thing is better than simply a list of things that are like the elements of the tab?
No.
Wait a minute. So you're not particularly pushing the tab version?
Well, the reason we went with tab, at least for the display for the tab over the list, was so that we could keep this as having a geometric scene head.
Okay, as opposed to a list of geometric scenes.
Right. And so if you had a list, if you format it as a list of geometric scenes, people are going to think it's a list when in fact it's not, because it's just a single geometric scene.
I thought actually Stephen meant list in a slightly general sense, like graphics row or something like this.
No, that wasn't what I meant. I meant an actual raw list.
No,
right.
Then we lose the head.
I understand. It loses its head.
I actually like the tab view because you can see the entire screen, because you always need to blow them up. And you can just see them bigger this way.
And the other reason I like to keep them together is if you have something really complicated and you want to derive conjectures, keeping them all together and using them all for the conjecture is, of course, much more efficient.
This discussion of angles is going to be a long discussion.
Yes, and a heated one.
And
It's
what?
always the simple things which are most difficult.
I said, and a heated one.
Right. This seems to be.
We discussed this since weeks internally.
Yeah.
And it's still just a 1D angle.
Correct.
But I sent just the papers for the Moody angles in n dimensions. So this generalization is easy. We just need general Moody arc hypergeometrics for it.
The heck the hypergeometrics have to do with it?
Actually, already a simple 4D angle generically is a tri-variate hypergeometric.
What do you mean by is? You mean for what?
Is
the measure.
For what?
For
you mean the angle measure,
integral, because
d omega.
it's a fraction of the sphere. area.
yes, exactly.
Okay.
Yes, I believe that.
I see what you're saying.
They become
So that's
quickly,
a
after
degenerate-
3 dimension, they become pretty complicated analytically.
What are they in 3D?
Elliptics.
Okay, so you're saying if you want to integrate over a small part of the sphere or the hypersphere specified by a certain angle, what is the surface, what is the measure of the surface of the sphere within that angle?
Yes.
Okay. So, but that angle might be, is that like a cone? Is that the?
Yes.
Yes. Yeah.
What is the area of a cap on a sphere? I should know that. It's not something obvious.
This is easy, but if an angle in 2D is basically 2 lines, meaning the simplest simplex, then the simplest version of the angle in 3D are 3 lines. It's not a cap.
Oh. I have no idea how you specify that.
You give a couple lines and say span the surface in between.
So it's a it's a spherical triangle.
Yes.
Yes.
Okay. Oh, I see. So the area of a spherical triangle. What is the area of a spherical triangle? Just, I mean, isn't it? It's not trigonometric. It's elliptic.
I don't know right now.
Okay. All right. Well, anyway, look, I think we should have a separate. I mean, but this is pretty nice, guys. I mean, this is really pretty nice. Can we follow up fairly quickly so we haven't lost context here? And we obviously need to.
And then leaves in a couple of days. So.
Right. I'm going to Portugal for a conference next week.
Talking about this.
Yeah.
Okay, so let's try and get this in like tomorrow-ish if we can.
Okay. Eric, did you hear or should I find email?
I think Eric is not here right now.
I wrote him.
I heard it. We're good.
Okay. Okay, great. So for those people who are on our live stream, we are actually about to jump to another live stream. So please tune in. We'll be there in just a couple of moments. All right. Talk to you, those who are not in the next meeting. I'll talk to you all soon.
Bye, everybody.
See you. Bye.